Good morning to all. I am Dr. Devasis Mohanty, working as Assistant Professor in the Department of Mathematics, SR University, Warangal, Telangana, India. So today I am going to teach you about the interval estimation. So how we can implement the interval estimation and how we can calculate the confidence interval and how to solve the problem using those concepts. So let us see the today's lecture based on the interval estimation. So coming to the lecture, so here we can see the definition of the interval estimation. So here the definition describes that the interval estimation is a statistical technique is used to estimate the population parameter by providing a range of possible values, right? So here you can see that interval is used to population parameter. What is the meaning of population parameter? That capital N parameter. So that is capital N of mu and sigma square. That is population parameter. Okay, students. So this provides a huge range that that is the outcome of the possible values. So here we can see these are very important things. Interval estimation offer a range within which the true parameter is expected lie with a specified level of confidence. So here that is basically specified level of confidence. Specified level of confidence would be there. Again, for example, signal processing. So whenever the signal processed that estimates the average noise level in communication channel with 95% of confidence. So here the confidence is 95%. That means 97 dBm to 93 dB. That is the range. That is the range. Okay, students. So this is about the interval estimates. Next, coming to the confidence interval. That is very important. So let us come to the confidence interval. Students, see, this is the definition of the confidence interval. So confidence interval for population parameter is an interval computed from sample data. That is computed from the sample data. That is the meaning is level of confidence is always that is very important. Level of confidence. So level of confidence is either 95% level of confidence or 99% level of confidence. 95 means that is 0.05 that alpha value and 99 means 0.01. Those values are very important. So here we can see students that theta is the population parameter. So which has theta cap is the point to estimate. So here the confidence interval is generally of the form theta cap plus or minus margin of error. Margin of error. Then let us discuss about the margin of error. Means what is the meaning of margin of error? So margin of error depends on there are some basic parameters which lies between the margin of error. So that is the standard error. First is the standard error. That is of the estimate. So we have to use the standard error of the estimate. Then we have this is the first point. And in the second point, you can see the critical value of the sampling distribution. Critical value of the sampling distribution. Right, students? Again, lastly, the confidence level. So confidence level means what is the meaning of confidence level? Either it is 95% or 99%. Right? So all of you clear? So this is about the confidence interval. This is very important thing. Confidence interval. Next, coming to the 95% confidence interval, what is the physical interpretation? Means when we can say that it is a 95% of confidence interval. So here you see a 95% confidence interval means if we take many random samples of population and compute the interval each time, that is 95% of those true population parameter. Okay. So here, student, here we see this is the upper limit. Upper limit is means 95% means what is that? Total is 0.05. In the upper limit, it is 0.025. Similarly, in the lower limit, it is also 0.025. So it is only affecting this result. It is only affecting this result. So this is the meaning of 95% confidence level. 95%. Right? Here one note is there. The confidence level reflects the reliability of the method used to construct the interval. It does not mean there is 95% probability that the true value lies within the specific interval. Okay, so that is the thing we have to do here. So next student, this is very important. The confidence interval for a normal mean. So we have to see for a normal mean how we can find the confidence interval. So here first we have to see when the standard deviation sigma is known. So we have to see when the standard deviation sigma value is known to us. Sigma value is known. So sigma value is known means we have to follow this formula, confidence interval formula. What is that? X bar plus or minus z alpha by 2 sigma divided by square root of n. Or we can take x bar minus z alpha by 2 sigma divided by square root of n, or else we can take x bar plus z alpha by 2 sigma divided by square root of n. So these two we can take here. Okay, understood? Right. So we have to know that what is the actual notation of those. So here x bar means the sample mean. That is very important, students. You have to know with respect to the sample, what is the mean is given. That is very important. So here x bar is representing the sample mean, and sigma represents the population standard deviation. The population standard deviation. N is the sample size, the actual size of the sample. That means either N value is 9 or 5 or 2 based on that. And next is Z alpha by 2. That is very important. That is only nothing but the critical value. That is the critical value that comes from the standard normal distribution. Standard normal distribution. So students, here standard normal distribution means Z table. Okay. So that critical value only we have to consider here to find the Z alpha 1. Okay. So let us revise this one. So here, first of all, we have to see in the question either the standard deviation is known to us or not. That is very important. Population standard deviation. That is sigma. Sigma is already is known to us or not. So if it is known to us, means if in the question the standard deviation is given, so we have to apply either plus or minus z alpha by 2 sigma divided by square root of n. Similarly, z alpha by 2 sigma divided by square root. These are two major formulas that we can see here. Okay. Right. Next, coming to our problem, let us see our problem. the confidence, this is the confidence interval for a normal mean. Normal mean means, so in the previous one we have seen about the sigma value is known to us. That means the standard deviation is known. But here the standard deviation is unknown. So what we will do if sigma value is unknown to us, means unknown in the question. So we can calculate the confidence interval by applying x bar plus or minus t alpha by 2. Here we have to apply t distribution, comma n minus 1 s divided by square root of n. Similarly, 1 is for plus, that means x bar plus t alpha by 2, n minus 1. What is the meaning of n minus 1? That is the degree of freedom, s divided by square root of n. And another formula is x bar minus t alpha by 2, comma n minus 1, s divided by square root of n. So these both formulas are very important to find the confidence interval when the standard deviation value is unknown to us, right? Means small sample. So in case of small sample, we have to apply the t-distribution formula. Okay, students. So here that S is the sample standard deviation. Why we have not taken sigma here? Because it is very small, right? So as it is very small, we have taken here S divided by square root of n. Normally we are taking sigma divided by square root of n. So here the sample size is small sample. That is very important. Small sample, right? Okay. Next, so here T alpha by 2 n minus 1 is the confidence value of T distribution, with n minus 1 is the degree of freedom. That is very important, students. Degree of freedom. Degree of freedom. That is nothing but the sample size minus 1. That is n minus 1. Okay. That is the degree of freedom. So we have to calculate the T alpha by 2 along with the degree of freedom. So degree of freedom is also important here. All right. Next, we have to see for the large sample. So here we can see the formula of the confidence interval. Confidence interval is equal to p cap plus or minus z alpha by 2 p cap whole into 1 minus p cap divided by n square root. So here p cap is the sample proportion. P cap is the sample proportion and n is the sample size. N is the sample size. Okay, students, so this is the formula to find for the large sample. If the sample size is large, so we can calculate the confidence interval by applying this formula. Okay, right. So what we have observed till now, we have observed three types. In the first type, we have to see the sample size is unknown. Sorry, the sample size is known. So when the sample size is known, we have to apply this formula. The standard deviation is also known. So we have to apply this formula. That means x bar plus or minus z alpha by 2 sigma divided by square root of n. Here the standard deviation is known. This is the first type. Standard deviation is known. In the second type, we have to see that is when the standard deviation is sigma is unknown. Sigma is unknown. Sigma is unknown means that's why we have written here S. That we have to apply the T distribution. That is T alpha by 2, comma degree of freedom. We have to see the T distribution table. Accordingly, we have to fix the value, right? So this is the second type actually. First type is already we have to apply the Z table. In this, the Z table means standard normal distribution. Second one is T distribution. We have to apply that T alpha by 2 and n minus 1. Okay, and that is very important for the large sample. So for the large sample, we have to apply here the confidence interval to find the confidence interval. That is this formula Ci equals to P cap plus or minus Z alpha by 2 P cap whole into 1 minus P cap divided by n square. That is the last type. Means sample proportion we have to calculate according to the sample size. If the sample size is large, then we can apply this formula. So based on these three formulas, we have to solve the problem. So from the question, you have to know that for which one, which standard deviation, which formula we have to apply. So if the standard deviation is known to us, then z value means x bar plus or minus z alpha by 2, you have to apply sigma divided by square root of n. If it is unknown, then t distribution we have to apply. Just by distribution, why you remember? Okay, and if the sample is large, so population, that sample proportion we have to calculate with respect to the sample size, right? Okay. So next, coming to the problem one, that is very important. From the question, you have to identify which distribution we have to apply. So try to read the question very carefully. Suppose that when a signal having value mu is transmitted from a location A, so value mu is transmitted from a location received in B. So suppose the same value is sent 9 times. The same value is sent 9 times. 9 times. So here the given 5, 8.5, 12, 15, 7, 9, 7.5, 6.5, 10.5. And let us to know that 95% confidence interval. Already I have told you what is 95% confidence interval. So students, here we have to calculate which formula we have to know. Sigma value is known or unknown. So here mean is given mu and variance is given 4. Okay, so here we have to apply that sigma value is known to us because variance is 4 means standard deviation is 2, right? Okay, students, let us gather the informations. So here sample size, first of all, we have to write n equals to 9, means small sample. And then sample mean, x bar value, that is from the question, this all these 5, 8.5, 12, 15, these values, we have to add these values. We have to add these values. Okay, 5, starting 5, 8.5 plus, we have to add these values plus the number of observations. Okay, number of observations. After applying this, 9 number of observations are there. Total is 81. So here you can write that is 81 divided by 9. 81 divided by 9, that is 9. So here sample mean is 9. After that, very important thing, that is the sample, that is the standard deviation. Standard deviation. So students, standard deviation sigma value is square root of the variance, that is 2. And the confidence interval. So here the confidence interval or confidence level, that is given 95%. Right? So Z alpha by 2 is 95%, means you have to see the Z table, that is 1.96. It is from the standard normal table. It is from the standard normal table. Okay. So these are the informations given. Now we have to implement the formula. These informations in the formula. So what is the formula, students? So this is very important for you students. So these are the tests, means whether it is a one-tailed or it is a two-tailed. Based on those, we have the level of significance. Either it is 0.01 or 0.05. So for the one tail test, it is plus or minus 2.33. Here it is plus or minus 1.645. For the two tail test, it is plus or minus 2.575, and second one is 1.96, plus or minus 1.96. So these values are very important. Here we have to see that is plus or minus 2.33 for one tail, that is 0.01, Level of significance means 99% level of confidence. So 0.05 means 95% level of confidence. So students, based on this, 0.01 means for the 110 test, we can find 2.33. And for 0.05 plus or minus 1.645. 2.33 means 99% means 0.9900. This normal table we have to follow. And 0.05 means 0.9500. This value we have to follow. For this value, we have to check the normal distribution in the 1.645 either we are getting and 1.96. Similarly, for minus 1.91 minus 1.645 will get and minus 1.96 will get for 0.025 value. So this is very important. These are the tests and these are the level of significance. So we have to follow the same to solve the problem. So let's coming to our problem. Here we see the standard error is given that standard error equals to sigma divided by square root of n. What is the sigma value? 2 divided by square root of n. What is the n value? 3. 2 by 3. That is the standard error. Next is margin of error. So margin of error is very important, students. Margin of error equals to formula is z alpha by 2 multiplied by standard error. That is 1.96 multiplied by 2 by 3. That is equivalent to 1.31. Right. So here the margin of error is z alpha by 2 into the standard error, that is 1.31. 1.31. Next, the confidence interval. Confidence interval, we have to calculate the confidence interval. So confidence interval is equal to x bar plus or minus e. That is equal to 9 plus or minus 1.31. Right. So that is either for plus we are getting 7.69 and for minus 10.3. So 90%, 95% confidence interval for the population proportion is either 7.69 or 10.31. Okay, these values are. Okay, students. Next, coming to a second problem. First problem already completed. If the sigma value is known, so directly z alpha by 2 we have to calculate. So next, very important thing is sigma value is unknown. So what we have to do there? So basically, it is for the small sample. So whenever there is a small sample, so try to read the question very carefully. We have to apply the t distribution here with the degree of freedom. Read the question. A teacher wants to estimate the average score of the students in a final statistics exam. She selects the random sample of 9 students from her class and record their scores. The sample has a mean score of 78.2 and sample standard deviation of 4.5. So construct a 95% confidence interval for the population mean score. That is very important, students. Here 9 students is given the number. Here the mean are given 78.2 and here the sample standard deviation. Standard deviation is unknown, that is 4.5. 95% confidence is given. Let's coming to the informations what are given. So I will write here n equals to 9. That is the small sample. Sample mean. X bar value is given 78.2. Sample standard deviation. S is given 4.5. Confidence level is given 95. So here the n value is less than 30 and sigma is unknown. Right? This is the condition. So we have to use the t distribution. We have to use the T distribution. So there is a table, T distribution table. So let us see the solution. First of all, we have to calculate the degree of freedom. So degree of freedom, DF formula. What is the degree of freedom? DF is equal to n minus 1, that is 9 minus 1, that is 8. Right? So next we have to calculate the critical value. So critical value means from the T table we have to see from the T table. So in the T table, DF equal to 8 and alpha equal to 0.05. That means T of 0.025 alpha by 2 and DF means n minus 1. N minus 1 is 8. So this value using the T distribution table, we can define 2.306. So after defining these values, we have to calculate the standard error. So how to calculate the standard error? Standard error is standard error equals to s by square root of n. So that is equal to 4.5 divided by square root of 9. That is equal to 4.5 divided by 3. That is 1.5. After calculating the standard errors, we have to calculate the margin of error. So how to calculate the margin of error? T alpha by 2 and n minus 1 multiplied by standard error. So standard error already we have already we got these values, that is 1.5. So t value we have to see here. So here this t values I got this t value. So here this t is 0.025 multiplied by standard error is multiplied with the standard error, that is 2.306 multiplied by 1.5, that is 2.459. Right. This is the margin of error. Margin of error we got is, that is 3.45. After finding this margin of error, we have to calculate the confidence interval. That is x bar plus or minus c. That is equal to 78.2 plus or minus 3.459. So after this value, either we are getting 74.741 or 81.659. These two values will get. Right. So this is very important. Okay, students. So this is the answer. Next, coming to the next problem. So this is the large sample. When sigma value is unknown and large sample, so what we have to do? We have to see here. In a political survey, 420 out of 600 randomly selected. So here the P cap is 420 divided by 600. Right? Confidence level is 95%. So that P cap value already we got. So we have to apply this formula. So already I told the students P cap is 420 divided by 600. That is 0.70. Right? Next is the sample size. What is the sample size is given? Means n value. N value is equal to 600. And what is the confidence level? Confidence level is given there 95%. So the Z alpha by 2 will be 1.645, that is as it is wanted. Okay, so that is 1.645, that is from the standard normal table. We are getting this value. Next, we will apply the formula to find out the standard error. So what is the formula to find out the standard error? Standard error equals to P cap multiplied by 1 minus P caps divided by n in square root. That is 0.70 multiplied by 0.30 divided by 600 square root. That is 0.21 divided by 600 square root. That is how much you will get? 0. Square root of 0.00035. nearly equals to 0.0187. This value will get, right? After finding these values means the standard error values, we have to see what is the margin of error. That is also important thing here. So margin of error E value is equal to Z alpha by 2 multiplied by standard error. Here the Z alpha by 2 is 1.645 multiplied by, that is 0.0187. The standard error, that is nearly equals to 0.0308. Right. So this is the margin of error. So after finding the margin of error, so we can calculate the confidence interval. So what is the confidence interval? That is equal to P plus or minus E. That is 0.70 plus or minus 0.0308. That values we are getting 0.6692. Second one is 0.7308. So this is the 90% confidence interval for the population proportion we are getting here. So these are the three types, means when sigma is unknown and small sample, and one is sigma is unknown, and when sigma value is unknown and large sample. For large sample, we have to find the proportion, sample proportion, and sample size value, and we have to apply the z alpha by 2, whether it is sigma value is unknown. And for the small sample case, we have to apply the t distribution. Okay, students. So here are two practice problems for you. Try to read this question carefully. We can get this. So the lecturer want to estimate the average marks obtaining by students in a midterm mathematics test and randomly sample. So n value is given here, 12 students, and the mean score is 72.6. Standard deviation is 5.2. So what we have to exactly apply here? So the Z table we have to apply here to calculate the answer. So answer is, just to verify this answer. Answer is one is 69.3, another is 75.9. In the second question, answer is 36.93, 45.67. Just to verify. Second question also like that. So means a researcher wants to estimate the average time students spend solving a statistical assignment and a random sample. So here the average time is given 41.3, and the confidence interval is 95%, and the sample standard deviation is 6.1. So accordingly we have to calculate, and accordingly we can find these values. Okay, students. So this is all about your means. Uh, how we can find the confidence interval, how we can estimate the interval, and after estimating the sigma value is known to us, then what we have to do. If the sigma value is unknown and sample size is small, what we have to do, and if the sigma value is unknown and large sample means sample proportion is given, so what we three types we have to see. Yeah. So I think all of you clear about this lecture. So next lecture we'll discuss more. Thank you all. Thank you for listening this lecture.